Dr. Heller has made some great contributions to the field. She directs the auditory lab at Carnegie Mellon University in Pittsburgh, Pennsylvania, where she is a faculty member in the Department of Psychology. Her research examines the human ability to use sound to understand events happening in the environment. This basic research relates psychological performance to acoustic properties and high level auditory information. Initially trained in brain and cognitive sciences at MIT, she received a PhD in psychology from the University of Pennsylvania and postdoctoral training in binaural hearing in the neuroscience program at the University of Connecticut Health Center. Since coming to Carnegie Mellon University in 2009, she's also become affiliated with CMU's Neuroscience Institute and CMU's Music and Technology program. She created the Sound Events database at auditorylab.org. She's an associate editor of the Journal of Acoustical Society of America and a founding member of the Auditory Perception and Cognition Society. Today, she is presenting results from a recent publication, reassigning sources of misophonic trigger sounds to change their unpleasantness, testing alternative mechanism with a new set of movies, paintings, and words. And then just a final reminder to avoid making any triggering sounds during this presentation. And I will be sharing screen in a minute for yours. Pull this up right now and we can get started.
Hello, and thank you for that introduction. I'm pleased to be able to talk to you today about some of my recently published research on misophonia. And next slide, please. Something happened. I can't see how the slides are shared.
I'm so sorry, Dr. Heller. Give me 1 second to make sure this
I'm just
is.
hoping you're on the slide, but I'm assuming.
Yeah, this is.
So
I'm sorry, everyone. I'm going to have to present like this. I cannot make it full screen.
Okay, please go back up one slide. Okay. Yeah, thank you. Perfect. Okay, so my lab at Carnegie Mellon University conducts basic research on auditory perception and cognition. For example, we study how people identify everyday sounds. Next slide, please. So the next slide, please. I don't see it. Okay, there we go. Thanks. The key idea I will be presenting today stems from some of our earlier findings about sound identification. We found that when people spontaneously misidentify a sound, they find it exactly as pleasant or unpleasant as the sound that they misheard it as. It has nothing to do with the actual sound they're hearing. So the next step in applying this finding to misophonia was to move from spontaneous misidentification to intentional misidentification through the use of visual input. And so we made movies that were designed to make misophonic sounds more tolerable by causing the source of the sound to be reassigned by the listener. So today I'll review some of the studies we conducted to systematically test which visual stimuli worked better than others and why. And we sought to understand the why because if we understand the true cause or the psychological mechanism for this effect, then we can generate new applications beyond the specific stimuli that we made. That's the goal. All right. So next slide, please. We'll be on this slide for a little while. First, I want to introduce some basic principles of sound and explain how that relates to the human ability to identify sounds. On the left, you can see a sound source. Hold on. Okay, my timer stopped there for a second. Okay. On the left, you can see a sound source. This is with the, spiky stuff coming out of it. By which I mean that is an object doing an action that makes a sound, and no sounds really occur unless an action has occurred. Okay, so one sound source can make a variety of sounds, and so the illustration is showing a sample of some possible sounds that are represented below the source, and that's represented as an acoustic waveform on the bottom left. The waveform is a variation in air pressure over time. That's what hits your ear when you hear a sound. And those waveforms can be produced by a given sound source, but the number that can be produced by any given sound source are vast. There are too many to memorize. Okay, so this isn't how people are recognizing sounds. We don't have memorized these waveforms. And this waveform, this fact means that many different sources of sound can also potentially create very similar waveforms. So if a whole bunch of different sources are making vast array of sounds, right? There can be some overlap in the waveforms. So now consider the problem faced by a listener who hears one particular waveform and they need to identify its source. That's illustrated on the right side of the slide. And we know that people can't be recognizing sounds by memorizing waveforms. I just told you that. So they must be using their cognitive system to look for common patterns in the waveforms and disregarding the irrelevant differences. And this process leaves room for error. For our key idea, we illustrate that a listener may recognize a given waveform as either coming from a misophonic source or a neutral source of sound. And by misophonic source, I mean a source that would make a sound that would be found to be misophonic by a listener. Okay. So, this is what I mean when I say that I study both perception and cognition. Perception of sound involves cognitive inference, not simply hearing a waveform. And so, to induce the misidentification I'm talking about in misophonic sounds in our studies, we constructed 44 movies in my lab. Next slide, please. So, how did we make these movies? We took inspiration from a special type of sound effect known as Foley effects, which I began studying over 20 years ago just to study sound identification. And these are substitute sounds that are made to help tell a story when it is difficult to use the real object. For example, the sound of a campfire could be imitated by using other safer objects in a Foley studio. To test our ideas in my auditory lab, we first made movies of misophonic sounds being produced, and then we recorded ourselves making similar misidentifiable sounds from neutral sources. We matched the timing of the videos so that we could pair the visuals from the neutral movie with the audio from the misophonic movie. Next slide, please. In the first study I'll talk about right today, we presented two types of videos to people with and without misophonia. We had 22 unique misophonic sounds, which were played to every subject in a random order. Okay. The top example on the top of this slide shows what happened in a trial in which a misophonic video, the video with a symbol with an M next on it, and the misophonic sound, which is a speaker symbol with an M on it, when they were paired in a movie. And after watching the movie, a participant rated the sound's pleasantness on a scale of -5 to +5, where 0 is neutral. So in this example, I circled red around the not -3 that's supposed to imply that this participant found this particular sound unpleasant with a score of -3. Okay. Then they rated how plausible it was that the event depicted in the video was the cause of the sound they heard, right? They could have just been like, I don't really buy it. But so half the participants first heard a given sound in this context that I've just described, but the other half of the subjects are shown in the next example below this, okay, in the slide. They heard the same sound, but paired with a neutral video, and that's shown by the movie symbol with an N on it. And they made the same types of ratings. So we measured actually the change across people, right, across groups of people. So one group of people heard this sound with the misophonic video first, the other group heard it with a neutral video first. And so the change in the sound pleasantness that we're measuring is the change that in the rating that's given to this sound in a different context. In the context here, I've shown that people that see it with a neutral video, they rated it maybe on average of +1. So that's a +4 points benefit or change in pleasantness when they're asked to rate the sound in that movie. So that's our core measure. Importantly, we also saw that the amount of change was related to how plausible the neutral sound source was. So if they didn't find it that plausible, it didn't really change the sound pleasantness that much. Next slide, please. Okay, so now we and others have shown that there's a robust effect of videos, and we would like to determine what the cause is. And we'd like to say that the cause is that movies caused people to reassign sounds to neutral sources, and that the source of the sound determines its pleasantness. After all, that's what we intended when we designed the study. But as scientists, we must always consider every alternative hypothesis, even the ones we don't want to be true. And so, fortunately, we have a great opportunity to test these questions by asking why some of our movies work better than others. We had a whole range of movies, and we didn't just say, "Oh, this one didn't work," and throw it out. We actually kept them all and did the whole study with good and bad movies. And that allowed us to use them as information. So in this pie chart, we lay out some of the alternative explanations that we considered for why the movies might help. The circle contains the entire beneficial effect of the videos. Okay. So let's suppose there was a +4 for a video, right? The +4 change we talked about before. That whole thing is filling up the circle. But we're illustrating that maybe half of it could be the orange part, which might be an illustration of the effect of the source plausibility that we just discussed, that we'd like it to be. But the other half of it could be divided amongst a whole bunch of other possibilities. And those are shown here, not as actual data, just an illustration of the notion. So you've probably already read these things while I was talking, but perhaps the videos help partly because they distract people from the misophonic sound, or perhaps it's the relative pleasantness of the neutral video imagery that actually helps, just seeing something sort of pleasant, or perhaps it's the perceptual similarity of the image to the sound, or perhaps the movies are that are technically better aligned are the ones that help the most. So we tested all of these alternatives in a series of 9 studies. I only have time to discuss 2 of them today. Next slide. So let's consider first one alternative hypothesis. Maybe the meaning of the movie doesn't have any effect at all. Perhaps the neutral videos are simply visually more pleasant to look at. And having something visually pleasant to look at improves sound pleasantness. Okay, so to test this hypothesis, we did a study in which we compared the pleasantness of the sound alone with the pleasantness of the sound when seen with a pleasant abstract painting. And some sample images are shown here. Now, some of you are already thinking, I don't find that painting pleasant, right? That's okay. We know that the pleasantness of abstract paintings is very individual. And so we personalized the images for each participant in a preliminary study before this one. Okay, so we found a small, reliable benefit on sound pleasantness from accompanying them with these pleasant images. But they're abstract and they don't have any meaning. So we have to ask why. When we showed this to people, we asked them to rate whether the image and the sound matched well. And that rating did not turn out to predict the size of the change produced by the painting for each sound. So in this case, we didn't use unpleasant images. We just compared the pleasantness of the sound alone in one set of trials to the pleasantness of the sound with the image, the pleasant painting in the other. So we're looking at, again, a change score, but it's not predicted by people's general ratings of the match with the movie. So what is? So to investigate this further, we looked at a scientific literature which shows that certain perceptual qualities are known to translate across the visual and auditory senses. For example, roundness versus sharpness can be used to describe visual images, but also to describe sounds. Similarly, calmness versus excitability, people will use those words to describe both. And so when the sound and the image match along these dimensions, perhaps this helps the image to improve the pleasantness of the sound. So to illustrate this idea, I'm going to ask you a question. Do you think the image on the left should be named Maluma or Takiti? Maluma or Takiti? So make up your mind. Okay, it turns out that most people agree most of the time that image on the left would be a Takiti and the one on the right would be a Maluma. And this body of knowledge inspired our next study. So in our study, we asked a new batch of naive observers to judge either a silent abstract painting, either a sound, nicely. Oh, okay. Right. We had to find out whether they were Maluma or Takiti. So we had this initial study showing that there's a pleasantness benefit. But why is it there? This is the study to find out whether they have that auditory visual similarity or not, right? So we had a new batch of naive observers, and they would look at a silent abstract painting, just the painting, and name it Maluma or Takiti, one at a time. And then we did the same thing with those misophonic sounds. Just hear the sound and say, is that a Maluma or Takiti? It sounds weird, but you probably all just did it. And so that's what their task was. So now we have a whole set of sounds and movies and images all named as Maluma or Takiti. And we could do a data analysis that just matched up whether if the sound was a Takiti and it was played with a Takiti image, then those would match. So that would suggest that the image maybe should help more. Similarly, Maluma and Maluma for sound and image should match. So it's not whether it's Maluma or Takiti, it's just whether they match. And then we also had sounds where it was like a Maluma image and a Takiti sound or vice versa.
Dr. Heller, this is Zach. I'm interjecting for just a moment. Are we on the right slide for you? Are you describing slide 8 or slide 9?
Yeah, I think we're on the right slide.
Are you sure? Okay, great. Thank you.
The one with the images. You're showing the images.
Yes.
There's four paintings. Yes. Okay.
No, there's only 2.
Oh gosh. Okay, move on to the next slide. Yeah,
Thank you.
everything I've been talking about. I forgot to say next slide. Sorry. Everything I've been talking about just now about this sort of perceptual matching was for this slide. So yeah, so on the left, top left there, just to orient you now, we've got completely different listeners just looking at like a image and saying, is it Maluma or Takiti? And then the one on the top, people said it was Maluma. So if there was also a sound that people said was Maluma and you put them together in a trial, then those would match, right? So the prediction is that the matching ones should help more. And it wouldn't matter if they're Maluma or Takiti, it's just the matching that matters. So we had 4 types of trials: Maluma, 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 Takiti, Maluma, Takiti, 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 Maluma. So we sorted the data that we got from that previous study this way, and we made the prediction that there should be a sort of a case where there's a match or a congruent image and sound, meaning that they kind of agree. We made the prediction, and we found that it was true that this images that matched the sound better were creating the effect, creating the benefit of pleasant paintings. The ones that didn't match, they didn't create a benefit, at least not as much benefit. The benefit is very small, but the benefit we found was controlled by that. That suggests that with no meaning attached, the reason some pleasant images can cause a greater increase in sound pleasantness is because those images share some similar abstract perceptual qualities. Okay, next slide. So just to summarize, what we have here is a completely opposite pattern of results for meaningful videos and abstract pleasant paintings. When stimuli with no meaning are paired with misophonic sounds, the agreement of their perceptual properties determines the increase in sound pleasantness. In contrast, when stimuli with meaning are paired with misophonic sounds, then the plausibility of the sound source determines the increase in sound pleasantness. Furthermore, by using pleasant images, we can put an upper bound on the size of this small perceptual effect. So how big is that slice of the pie potentially from pleasantness, right? And we can say it's really not that big. It can't account for the majority of the beneficial effect that we were seeing from our videos. So that we have found out from that study. And now I have a minute to tell you about the next study, which is that we went in the opposite direction to dissociate the effects of source meaning from all the other possible visual effects of videos by conveying. We're on the next slide, right? Yeah. Okay. No, next slide, please. Sorry. Yeah. By conveying the content of those videos just with words. So there would be a description of a person doing blah blah blah, whatever that action is. That's all they saw. They didn't see a video, but they heard the sound. So it was exactly parallel to the first study I told you, but they just saw a description instead of a video. And we found that there were increases. The illustration, the example here, we show that there's an increase or a change caused by this, but it's like only 2 points instead of 4. That sort of illustrates that the descriptions have a strong beneficial effect, and it's again moderated entirely just by source plausibility. There's no visual pleasantness happening, and it kind of follows the exact same function as the earlier one. So quantitatively, it agrees that the amount of plausibility predicts how much it changes. So our takeaways: in summary, we can make misophonic sounds less unpleasant in a number of ways. We understand why each one works. And videos, are the most potential, most potent, but the verbal descriptions do work almost as well, and they're much more flexible. And the QR code here goes to the slide. If I may very briefly mention that we have also this year put out 2 papers that show physiological effects. Everything I've talked about today was behavioral effects, just on ratings, people's actual perceived experience. These are done trying to find physiological correlates of that with pupillometry, and we found them for sound alone and also for these videos. Found some interesting results there. So, and then just want to acknowledge everyone who helped. Thank you for your attention.
Thank you, Dr. Heller. Your work is absolutely fascinating and it builds incrementally on some recent findings. And it's really exciting to see where your work is elevating past findings. And I think I speak on behalf of everybody who's so interested to see where all of this work goes in terms of clinical interventions. So we have 1 minute for questions, and that is going to be my question. It's from Christoph and others. Sarah agreed with this question in the chat. So thinking about translation and kind of clinical applications of this work, what would you say would be now or maybe in the future, which medical professional or maybe what type of doctor or healthcare provider do you think could help with this technique of kind of tricking the brain using the trigger sound combined with some plausible video? What do you think? Where does this go clinically?
Well, of course, cognitive behavioral therapists, psychotherapists could use this. Also, it could become a standard type of practice in audiology, just like audiologists have taken over some training for other kinds of sound issues. So I think both of those could. And I think that the thing that has the most translational potential is the verbal descriptions, because they're so flexible, and we didn't even make them as good as they could be. So I would hope that we could maybe come up with, any practitioner could come up with a set of verbal descriptions and ideas much more easily than a set of videos. So that's where I see it going.
Thank you so much for that. Thank you for your work. And we're now going to take a transition here out of Dr. Heller's presentation. We're now going to shift gears and have our first breakout conversation group. So go ahead, if you're interested in joining the larger conversation about research, go ahead and go to home on your screen and click, and we will see you in the breakout conversation group. Thanks, Dr. Heller. Enjoy your vacation.